You've already seen how to solve integrals using partial fractions, but I just want to show you another method that might be a little more intuitive for you or help you go through these a little quicker. And really, we're going to apply this method to some upcoming videos. So that's why I want to introduce it here with something that you're familiar with. So let me just pull out this integrand here and start to write out some partial fractions for it, partial fraction setup. So there's our integrand. And let's write out a partial fraction setup for it. Let me do that in white, and then we'll switch some colors. So this is equal to, and you've already seen this. This is a over x plus 1, and then we got plus, go yellow, b over x plus 2, and then plus, let's go pink, c over x plus 3. So you've already seen this. This is writing out a partial fraction setup. And now I told you I want to show you a new method. And what we're going to do under this new method is we're going to attack A first. We're going to show it on A. And really, the first part is to just do some algebra. So what we're going to do is multiply both sides by x plus 1. So both sides by x plus 1 here. And what happens when we do that? Well, on this left-hand side, x plus 1 cancels. Okay? And then when we distribute this to all of our terms here, we see that looking at A, the numerator and denominator are going to cancel. And then we can do this. So this already got distributed. Then we can do this. To find A, we're going to let x be equal to what? We're going to let x be equal to negative 1. And you can see what happens. When we let x be equal to negative 1, this term here goes to 0. And so does this term. And we're only left with A on this right-hand side. So we're left with A, and it's going to be equal to this left-hand side evaluated at x is equal to negative 1. So that is negative 1 squared. And then we have plus 5 times negative 1, and then plus 7 in that numerator. And then denominator, we're going to have negative 1 plus 2, and then times negative 1 plus 3. And what do we get here? That is going to be 1 minus 5 plus 7, and then we're dividing that by, let's see, 1, and then we have a 2 here. So 1 times 2, so this is 8 minus 5, that is 3 over 2, and boom, we found A. So that is going to be our method here. And what I want to do is tell you its name. Let me just clear this real quick, and we're going to apply the same thing to find B. So if you want to pause the video and try to find B under this method, if you feel like you've seen it enough, try to find B and C. But now that we've cleared this, what I want to say is that this method is called the cover-up. This is called the cover-up method. And I have these rectangles over here for a reason. I want to show it under finding B. So we're going to find B next. And what do we need to let x be equal to in order to find B? So we're going to let x be equal to, and that's going to be negative 2. And you might say, whoa, we can't do that. That's going to be dividing by 0. It'll be undefined. We can't do that. But really, what's happening in the background here is you could do the same thing that we did with A. You could multiply both sides by x plus 2, and you would see the same thing that played out with A. These would cancel. So we're not dividing by 0 here. And I brought these rectangles to show why we call it the cover-up method. When we let x be equal to 2, let me pull down these rectangles now. This is what happens. This is going to be covered up, and so is that A term, and then x plus 2 gets covered up, and so does x plus 2 on this side. And then all we do is evaluate this left-hand side at x is equal to negative 2, and we found B. So that's why it's called the cover-up method. And you can see when you don't have to write everything out, this can start to become pretty quick. So that is the utility of it. So let's find B here. So let's grab a little more space. And we are going to say that B is equal to, and what is this left-hand side at x is equal to negative 2? So that's going to be negative 2 squared. And then we have plus 5 times negative 2, and then plus 7. So that's numerator. Denominator, we're going to have negative 2 plus 1, and then multiplying that by negative 2 plus 3. So what is this? This is going to be 4. So this is 4 minus 10 plus 7. So that looks like 1 in the numerator. And then denominator, this is going to be negative 1 and then times 1. So this comes out to, we have 1 in this numerator and -1 in the denominator. So this is -1. So B is -1. So we just found B. And now we're going to do the same thing to find C. So let's clear these covers real quick. Let's clear these covers and do the same thing to find C. And again, pause the video. Try this out. Try to find C. Try to find C. All right. Let's go find C. Let's get pink going here. So we're going to find C next, and maybe we can work through this guy just a little quicker. What do we need to let x be equal to find C? We're going to let x be equal to -3. And let's throw our covers on. So we're going to cover up B and A, and then we're going to cover up x plus 3 on this side and x plus 3 on this side. And then again, all we do is evaluate this left-hand side at x is equal to -3. So let's do that. Let's see here. That C is equal to, and that's, maybe we can go through this a little quicker. So this is going to be 9, and then we're going to have -15, and then plus 7 in that numerator. And then denominator, this is going to be -2, it looks like, and then we're going to have -1. So this comes out to 16 minus 15, that's 1, and then we have 2 in this denominator, so C is 1/2, and we just found A, B, and C, and that is through using the cover-up method. Lastly, let's finish this problem up. Let's clear these covers, and we'll go back up and solve our indefinite integral. So let's get those out of the way, and then we'll come back up here, and let's solve this indefinite integral with what we found. So we have what here? Let's get this going. We have this. This is equal to the indefinite integral, and then all we do is fill in our partial fraction setup. So we found that A is what? 3/2. A is 3/2, and then over, this is x plus 1, and then we have plus, let's go yellow. We found B to be -1, so that is -1 over x plus 2, and then we have plus, and then C is 1/2, so we have plus 1/2 over x plus 3, and all of this is being integrated with respect to x. And what you could do, again, this is a super easy integral to solve. What you could do is split this up into 3 separate integrals if you'd like, or what we're going to do is actually just skip that step and write down the answer. So this comes out to 3/2 times the natural log of the absolute value of x plus 1, and then we have plus, actually we'll keep this minus, we'll go minus the natural log of the absolute value of x plus 2, and then we're going to have plus 1/2 times the natural log of the absolute value of x plus 3. And then since we have an indefinite integral, we can't forget that plus c. So that is our answer here, right here. There's our answer. And you saw a method earlier that you learned, and now you have this new method called the cover-up method. And it's going to help us in the upcoming videos when we have some more complicated partial fraction setups that will help us save some time on some easier terms to find.